तो वो क्विकली कर लेते हैं कि that's known as hydrogen bonds. So that's known as hydrogen bonds, or remember that's not actually a bond. It's actually an intermolecular force. और इसमें होता क्या है कि what happens in this is that it's what you can think of it as a stronger version of a dipole. ठीक है, a much stronger version of a dipole. मतलब obviously ये लिखना नहीं है तो इसलिए मैंने ब्रैकेट्स में लिखा हुआ है, but it's a stronger version of a dipole. How do you have a stronger version of a dipole? कि you need a very electronegative, you need an element with very high electronegativity. अच्छा, तीन elements that have very high electronegativity. So there's oxygen, nitrogen, and fluorine. ठीक है, नाइट्रोजन भी होता है और आपके पास फ्लोरीन होता है, and they must be bonded to hydrogen directly. अच्छा, must be bonded to hydrogen. और तीसरी चीज है the lone pairs must be available. अच्छा, high charge density lone pairs, they got to be available. अच्छा, so you need oxygen, nitrogen, fluorine, and they should be bonded to hydrogen directly. So for example, if I have HF, so HF there's a huge difference in electronegativity. That's the first thing, because F is extremely electronegative. So it's got this very huge difference in electronegativity. So there's a very strong negative charge and there's a very strong partial positive charge on the hydrogen atom. So the dipole is really strong. But apart from that, the dipole is also extremely strong is because fluorine has 3 lone pairs. उसके पास फालतू के electrons ना बहुत ज्यादा है. ठीक है, so it's got a bunch of lone pairs, and they're high charge density lone pairs. Why are they high charge density lone pairs? क्योंकि as the reason they are high charge density lone pairs is that fluorine is a very small atom. So the lone pairs are like the electrons are very concentrated. They're all very tightly packed. तो मैंने पहले बताया था कि if the charge is like really dense, ठीक है, and if बहुत छोटे atom पे ना, if you have a lot of charge, then the charge is more effective. So there's one HF molecule and there's another HF molecule. So unlike a normal dipole, this dipole is kind of like a lot more stronger. So that is the main difference between a dipole, a permanent dipole, and a hydrogen bond. It's just a stronger version of a dipole, and the force of attraction between them is therefore going to be very very strong as well. तो इनके बीच में जो force of attraction है, that is going to be, and the force of attraction is basically the lone pair of the fluorine, the negative lone pair of fluorine with high charge density is going to attract strongly the positive H from the other atom. तो ये clear? Is this part clear?
जी सर.
तो एक तो H को F के साथ डायरेक्टली बॉन्डेड होना चाहिए, प्लस लोन पेयर्स अवेलेबल होने चाहिए. Dipoles were already very strong, but now they're even stronger. So molecules that have hydrogen bonds, they usually have a lot higher boiling points. ठीक है. Water is one example. So there's another example. Let's do that quickly. Water. अच्छा, water में होगा कि there's an oxygen, or 104.5 is the bond angle. So that oxygen is bonded to 2 hydrogens. And let's say there's another water molecule, and it's a kind of the same thing. Okay, there's another water molecule, and अच्छा अब H जो है वो that's partial positive. This H is partial positive, and you've got lone pairs which are extremely negative. And here's another water molecule, and same thing. This is negative, partial negative. The H is strongly positive. This H is also strongly. So this H is also strongly positive, and the same thing will happen that uh, the positive H will get attracted. अब इसमें वही ख्याल रखना है कि the positive H will get attracted to the lone pair, to the negative lone pair. So you have to show this. I mean, you have to be very careful when you draw this. वो sketch करने को कहेंगे, so you have to be very careful about this. And also remember that due to orientation, due to the shape of the molecule, due to the shape of the molecule, you can't have too many hydrogen bonds between water molecules. Like angles different. Okay? If you have a lone pair over here, the other lone pair will be repelled and it will be pointing in some other direction. So that other lone pair might form hydrogen bonds with some other H, but it won't form hydrogen bonds with this H. So though water molecules, there's only one hydrogen bond that's possible. The other ones, I mean, this positive H, that might be pointing in some other direction. So molecular geometry है ना, ये एक lone pair इसी the point करा, all the other things will be pointing in some other direction. ठीक है? So between water molecules, only one hydrogen bonds would be possible. You can have वो आगे जाके it can form a hydrogen bond with some other water molecule, but not the same molecule. यहाँ पे lone pairs हैं, so there's going to be a force of attraction. ठीक है, तो idea clear है? Hydrogen bonding clear है? Is this thing clear?
जी सर।
और इसके पास examples कर लेते हैं कि you have whenever you have O, N और F bonded together, so you will have hydrogen bonding. So let's do ethanol or methanol बल्कि. Methanol is the same thing, like you've got अच्छा methanol में you've got CH3 और OH है. ठीक है, तो उसमें भी यही होता है कि 104.5 degree angle around the oxygen atom. There'll be lone pairs on the oxygen, which will be very negative, and the H will be very strongly positive. So if there's another methanol molecule, then they would get attracted to each other. So let's say there's एक और methanol का molecule है, ये ऊपर draw कर लेते हैं. So it's got an O. ठीक है, ये CH3 है. You got H over here, and you've got lone pairs. The negative lone pairs will get attracted. So the negative lone pairs will get attracted to the positive H of the water molecule. तो आपको इस तरह वो draw करने को कहेंगे. अब remember कि अगर lone pair नहीं है ना, तो there won't be any hydrogen bonding. So NH4+1 का example, any molecule that doesn't have lone pair, I mean, although it has oxygen, nitrogen, fluorine, and they might be bonded directly to H, लेकिन अगर lone pairs नहीं है, they won't have hydrogen bonding. So the next thing is molecules that have, अच्छा अब एक ग्राफ वगैरह कुछ याद रख लेना, क्योंकि they'll ask you questions which will be very similar to this. They'll ask you something like this, okay, what's happening, okay, बल्कि उसका ना वो कॉपी कर लेते हैं वहां से, ग्राफ ही कॉपी कर लेते हैं. अच्छा, हाइड्रोजन हैलाइड्स बॉइलिंग पॉइंट्स. अच्छा, अब हाइड्रोजन हैलाइड्स के बल्कि इस ग्राफ में सारे ही गिवन है। अच्छा, अब अगर इस ग्राफ को देखोगे ना, यहाँ पे कॉपी नहीं हुआ। अच्छा, ये हमारा ग्राफ आ गया। तो इस ग्राफ को देखे ना, they'll ask you कि भाई what's going on, कि the trend of hydrogen halides is कि you have HCl, HBr, HI, और फिर then you've got HF all of a sudden, and the HF has pretty high. अच्छा, the HF over here has pretty high boiling points. तो फौरन पूछेगा कि भी इसका इतना हाई बॉइलिंग पॉइंट क्यों है। सेम इज द केस विद वाटर, व्हाई डज इट हैव सच हाई बॉइलिंग पॉइंट्स, क्योंकि बाकियों में दे जस्ट हैड डायपोल्स। ठीक है, दीज वंस ओवर हियर they only had dipoles, and the dipoles are kind of weak. तो ये सारे only permanent dipole, so they just had permanent dipoles. मैं ब्रैकेट में प्लस वैन वॉल्स कर लेते हैं, वो अभी हमने किया नहीं है वैसे। और इन दोनों का क्या मसला है? Both of these, they've got strong hydrogen bonding happening. They've got a very strong dipole, which is why the boiling points are a lot stronger. ठीक है, so they're forming strong hydrogen bonds. So you clear any molecule that has hydrogen bonds, it's going to have a much higher melting or boiling point. Is this clear?
जी सर।
अच्छा, अब ये कि अगली जो last force है, which is van der Waals forces. अच्छा, this last one is always present in molecules. ठीक है, so van der Waals forces. So our third one is van der Waals forces. जिसको सारे नाम थे different. It's instantaneous dipole, induced dipoles. और या फिर इसको वो कहते हैं dispersion forces. तो ये सारे नाम थे इसके। अच्छा, van der Waals, instantaneous dipole, induced dipoles, or dispersion forces. First thing is this intermolecular force is always, it's always present in molecules. And it's negligible, or you can simply ignore it in smaller molecules. So it's a negligible force in smaller molecules. हाँ, अगर bigger molecule होगा, then it's going to be much stronger. तो छोटे मॉलिक्यूल्स में आप इनको इग्नोर ही करते हैं कि, I mean, you don't really talk much about van der Waals forces. Bigger molecules lot stronger. तो वापस इसमें आते हैं, what is this force? This force is in any molecule, and specifically when a molecule is non-polar. For example, if I have a chlorine molecule, so chlorine molecule के अंदर there is no dipole. Because both chlorines they attract electrons, they're equally electronegative, so they attract the electrons with equal force. So if they're attracting electrons with equal force, the dipoles will get cancelled out. ठीक है, the electrons will just remain evenly distributed. लेकिन होता ये कि when you have a chlorine molecule and you've got lots of chlorine molecules, ठीक है, they're all colliding with the walls of the container, ठीक है, they're bumping into each other, तो chlorine gas होती है. So there'll be lots of these molecules. Now, when these molecules they bump into each other for a very temporary instant and for a very random instance, the electrons might get knocked to one side. ठीक है, हो सकता है collision के अंदर electrons very slightly get knocked to one side. ये negative हो जाता है and this side becomes positive. That's known as an instantaneous or temporary dipole. ठीक है, for some random reason. So this one is your instantaneous dipole. And it might vanish the very next second. But what it does is it induces a dipole in these other molecules, because if this side is negative, so iske jo electrons honge, they're going to get repelled by the neighboring molecule as well. And that will get a dipole induced on it as well. ठीक है. अच्छा, ये वाली side positive है, तो it will attract electrons from the other molecule, neighboring molecule, so its electrons will get attracted to this side and this side will become positive. ये positive है, so it might attract electrons from the neighboring molecule and the electrons will be towards one side compared to the other side. And वहां पे एक side negative होगी, the other side is positive. So one instantaneous dipole creates induced dipoles in the neighboring molecule. अगले second हो सकता है the whole picture might be different. ठीक है, maybe the dipoles vanish. Or maybe what happens is that now you've got an instantaneous dipole where the electrons, like there's a collision happening and the electrons get knocked to the other side. So this side becomes negative, this side becomes positive. So if this is positive, then instead of repelling electrons from the neighboring molecule, it will instead attract its electrons very slightly. So ये वाला negative हो जाएगा, ये वाला positive हो जाएगा और induce होते जाएंगे dipole. So what is happening is basically there's a random fluctuation of dipoles happening. So your electrons are not, even if they are evenly distributed, they're not always evenly distributed. They get knocked to either side, kabhi is side pe, kabhi is side pe, which is why it's not a permanent dipole. It's always a temporary instantaneous dipole. And because of that, it always induces dipoles on the other molecules. And because of that, there's a force of attraction that's going to exist. The negative part of one molecule will attract the positive part of the neighboring molecule. और ये random fluctuation चलती रहेगी. Sometimes ये सारे dipoles गायब हो जाएंगे. Next second, some random dipole will be created and induced dipoles will get created. So idea clear है the fluctuating dipoles that are forming over here. Is this clear?
Yes, sir.
So that's van der Waals forces. But remember, it's weak because it's on average it's weak. कि आप on average लगाओ तो अगर टाइम स्केल को मैं थोड़ा बढ़ा लूँ, let's say 2 सेकंड के लिए डायपोल फॉर्म हुआ था, 1 सेकंड के लिए गायब हो गया, फिर अगले 3 सेकंड के लिए कोई डायपोल फॉर्म हुआ है, फिर 2 सेकंड के लिए गायब हो गया. तो on average the force is kind of fluctuating. It's like it becomes stronger, it becomes weaker. So you talk about van der Waals forces on average, and overall it's going to be weak. It's not going to be that strong. Achha, why is it negligible or very weak in small molecules, and why does it increase with size? बड़े molecules होंगे तो क्या issue होगा?
सर्कुलेशन के चांसेस इंक्रीज हो जाते हैं.
अच्छा, 2 factors होते हैं जिससे ना इनकी strength increases. Number 1, bigger molecules have more electrons. So that results in stronger temporary and induced dipoles. यानी अगर मैं कहता हूँ ना फ्लोरीन का मॉलिक्यूल है, So the fluorine molecule has a total of 9 plus 9. That's बल्कि हाइड्रोजन के साथ कर लेते हैं. अगर मैं कहता हूँ हाइड्रोजन का मॉलिक्यूल है, that's a total of 2 electrons in this entire molecule. वो भी बीच में है. अब now sometimes those 2 electrons will be on one side. Sometimes they might be to the other side. ठीक है, so they would be fluctuating. These 2 electrons will be getting knocked out. तो कभी ये साइड थोड़ी सी नेगेटिव हो जाएगी, कभी वो साइड थोड़ी सी नेगेटिव हो जाएगी. But compare this to iodine. Iodine has a total of 53 plus 53, that's 106 electrons. Now imagine agar 106 electrons for a very temporary instant, they get knocked to one side. So the negative charge and the positive dipole that's going to be created because of that would be huge. यहाँ पे जो dipole create होगा ना, instantaneous dipole, that's going to be really tiny. क्योंकि 2 electrons ही एक side पे गए ना. So is this idea clear that bigger molecules have more electrons and that results
जी सर.
अच्छा उसकी वजह से ना that results in very strong अच्छा that results in very strong dipoles. और second जो part है ना वो है कि जिसमें होगा stronger instantaneous and induced dipoles. अच्छा second part है, एक से रुकना. Just one second. अच्छा, bigger molecules have more electrons and stronger induced dipoles. That's one thing. And the second is the second factor. That second factor is, बल्कि इसका example भी कर लेते हैं कि if you talk about where do you see bigger molecules having more electrons and stronger van der Waals forces. One example is group 17. If you look at group 17, the fluorine is a gas in non-polar, so they only have van der Waals forces. Chlorine is always also a gas. Bromine happens to be a liquid. And iodine is actually a solid. So that means iodine has a lot stronger force of attraction. So bade molecules hote hain, they become solids. And the main reason is you've got more van der Waals forces. And you have more electrons, more instantaneous dipole induced dipole. Second factor, jo hai, that's about the shape of a molecule. That's the second factor, shape of a molecule. Now remember why were instantaneous dipole being produced? Because you were having collisions. Molecules were randomly colliding with each other. The molecules that have a large surface area have more collisions. I mean, they're bound to have more collisions. The larger surface area, you get more collisions, more chances of instantaneous random dipoles getting created. The larger molecules, not larger, molecules having more surface area. So molecules having more surface area will have more instantaneous, will basically have more collisions. And because of that, we'll also have more instantaneous dipoles. अच्छा, they're going to have more instantaneous dipoles. So shape of molecule बहुत important है. और and here's the example. It especially applies to organic chemistry. So if I have a molecule where, let's say, there are 5 carbon atoms, and those 5 carbon atoms, it's a long chain. तो ये CH3 है, ये CH2 है, CH2 है. So you've got another CH2, and then you have a CH3. So if you have a long chain, that's got a lot more surface here compared to the same molecule with the same size. It's an isomer, but it's relatively smaller in size. तो इसका जो इलेक्ट्रॉन क्लाउड होगा ना, जो इलेक्ट्रॉन्स होंगे, because the molecule is more compact, it's obviously going to have fewer collisions. This one is like really spread out. So this one is going to have more interactions with other molecules. इसकी collisions वगैरह ज़्यादा होंगी, ठीक है, everything will be more. So this one is going to have more van der Waals forces. Is this idea clear?
जी सर.
अच्छा, remember कि van der Waals forces will always exist in all molecules, even if it's got a dipole, even if it's got इन सारों में भी है कि let's say you've got a molecule that has hydrogen bonding, right? लेकिन उधर भी ना, the electrons will be kind of partially, although it has a permanent dipole, I mean the fluorine will always be negative, लेकिन there will be some fluctuation that will be happening on top of it. Electrons जो है वो constantly, man, it's not going to be, sometimes it's going to be slightly more negative, sometimes it's going to be slightly less negative. There's going to be fluctuation happening. There will be van der Waals over here as well. और उसी तरह ना, ये जितने भी हमने permanent dipoles भी किए थे ना, shape wise और वो सारा, HCl वगैरह में भी ये होगा कि even though it has a dipole, but because of the fluctuation that's going on, there will be van der Waals forces as well. चलो ठीक है, ये फिर कंटिन्यू करते हैं नेक्स्ट टाइम. ये भाई वो तो कंप्लीट हो गया. We'll just do past paper questions related to intermolecular forces. Is that clear?
जी सर.
चलो ये फिर कल कंटिन्यू करते हैं, ठीक है?
ओके सर.
ओके, अल्लाह हाफिज.
अल्लाह हाफिज.